guys, today we're going to learn about factoring trinomials using the box method. And yesterday we learned about finding the GCF of the trinomial and being able to pull that out. So that's going to be the first thing that we want to look at again today. We want to check to see first if our trinomial has a GCF. If it doesn't, we're then going to factor it. So let's look at the trinomial that I have here, n squared plus 9n plus 20. Is there a GCF between the three parts that I have here? Don't forget, there's a coefficient of 1 here. So do they have any number in common? No. Do they all have an end? No. So is there a GCF? No, there is not. So I'm just going to move on, and I'm going to go ahead and use my box method to be able to factor this further, since there is not a GCF for me to pull out. So first, create a 2 by 2 box, which I've done for you here. Second, in the top left corner, put the first term. So my first term is n squared. I can put the 1, I don't have to put the 1. And in the bottom right corner, put the last term, which is 20. So I have my, let me make this a little bit bigger here. I have my n squared and my 20 from step 2. Step 3 is to multiply these two terms together. If I multiply these two terms together, I would get 20n squared. And that's what I want to put here. Find the two factors of 20n squared that when added together will give you the middle term. The middle term in my trinomial is 9. So I want to find the two factors of 20n squared that when added together will give you the middle term, which is 9n. What are they? So think about this. What am I going to break 20n squared in? If I have two n's, each one gets it. What two numbers multiply to give me 20 and add to give me 9? And they are 5 and 4. So 5n times 4n gives me 20n squared when I multiply it. So 5n times 4n equals 20n squared. And 5n plus 4n gives me the middle term, which is 9n. So put these, 5n and 4n, put these into the boxes. It doesn't matter which one you put where. Because from here, I am going to factor each row and factor each column. So I was left with this. Find the GCF of every row and every column. Look at this column here. What's the greatest common factor? The n. What's the greatest common factor here? 4. So I found the GCF of the rows. Now find the GCF, I found the GCF of the columns. Now find the GCF of the rows. The GCF between n squared and 4n is n. Between 5n and 20 is 5. Now remember, if you forget how to find the GCF there, so if I was looking at this row right here, n squared and 5n, break it down, do the factor tree. N squared means I have an n and an n. 5 is just 5, and n is just n. So these two give me n. This one gives me 5n. The GCF is whatever they have in common. In this situation, they only have an n in common. That is how I got this n up here. So remember, like we went over this yesterday, you can do that for everyone that you don't know. So that's what I'm left with on the top and on the bottom. Step 5 says to the sum of the factors in the columns and the sum of the factors for the row, write it as your polynomial factors. So what you're left with here is n plus 4 and n plus 5. So my trinomial that I had, n squared plus 9n plus 20, broke into two binomials, and these two binomials are my answer. So I have successfully factored my trinomial. Now previously, in the beginning of the year, we knew how to solve these. And when we had a binomial times a binomial, we used the box method to get my answer. So all I'm doing is working backwards here. Backwards from what I already know. All right, let's go ahead and look at the next one. So this one is n squared plus 3n minus 18. First, always check to see if there is a GCF. And if you can pull one out. And there actually isn't. Create your box. I gave you your box. Second step is to, in the top left corner, put the first term, and in the bottom right corner, put the last term. So I'm going to go ahead and put my n squared up top, and the bottom right is my negative 18. Step 3, remember from step 2, I just have to add my step 2 in there. So this is what I had from step 2. Now step 3 says multiply these two terms together. If I multiply them together, I get negative 18 n squared. I'm going to write down what the question actually was so that we can see in 1 second. So find two factors that multiply to give you negative 18n squared, and they add together to give you the middle term, which is 3n. So break down my negative 18n squared. If there's two n's, each one has one. If it multiplies to give me a negative, the sign has to be one of each. So what are some factors of 18, one of them being a negative number, one of them being a positive, that could give me, that could add to give me positive 3? Would negative 9 and 2 work? They multiply to give me 18, oops. They multiply to give me negative 18n squared, but do they add to give me what I had up here, which is 3n? They don't add to give me 3n, so is this situation going to work? No. Well, what if I went ahead and switched it around to negative 2 and 9? They multiply to give me negative 18n squared, but do they add to give me positive 3? No, so it clearly is not these factors. So let's try negative 3 and 6. They multiply to give me negative 18n squared. Do they add to give me positive 3n? They sure do. So those are my factors. Remember, it doesn't matter which one you put in the boxes that are left over. So it gives me negative 3n and 6n. Put these into the boxes. Doesn't matter where you put it. Next step. And 6n, negative 3n, negative 18. Next step is to factor the terms in each row and column. Find the GCF of every column and then every row. What's the GCF in this column right here? Is n. What's the GCF in this column? It's just 6. What about if I go to this row? The GCF here is n. What's the GCF here? Notice they both have a negative. Take the negative. And the GCF would be negative 3. That's the number they have in common. So this trinomial these two are my binomials. So break them down and show it. n plus 6, n minus 3. It doesn't matter which one you put first. So I have successfully factored that trinomial. Could I very well go ahead and multiply these two by boxing it again to see if I get what I started with, if I got my answer? I sure can. All right, let's go ahead to the next one. A squared minus 2a minus 3. GCF, is there a GCF here? There is none. Remember, if you can't realize that right away, go ahead and do factor 2 for each one. First term goes up top, last term goes in the bottom right. Go ahead. Go ahead, multiply these two terms together to get negative 3a squared. And I want to find two factors of negative 3a squared that when added together will give me my middle term. What is my middle term here? And my middle term is negative 2a. So what are the factors here of negative 3a squared? Remember, if there's two a's, each one of them gets it. If they multiply to give me a negative, the sign gets one of each. Well, the only factors of 3 are 3 and 1, so which one would have the negative sign if I want them to add to give me negative 2a? Very good, the 3 would be negative. These multiply to give me negative 3a squared, and they add to give me the middle term, which is negative 2a. So the factors are negative 3a and 1a. It doesn't matter which one you put where in the box. As long as you do your work correctly, you're going to be fine. Now go on to step 4. Pull out the GCF of every row and every column. What's the greatest common factor here? And it's just a. What's the greatest common factor here? It's just 1. Now my rows, the greatest common factor between these two is a. The greatest common factor here, notice they both have a negative. Take the negative out. And the greatest common factor is 3. So this trinomial that I have up here, a squared minus 2a minus 3, breaks into these two binomials, a minus 1, or a plus 1, sorry, this one is positive, and a minus 3. It didn't matter which binomial I put in which spot. That would be my answer. So I could put it as a minus 3 and a plus 1. It doesn't matter which one goes where. These both mean the same thing. If I doubted my answer, box it back up or foil it. Some of you like to foil to see if I get what I started with. All right, let's try this one. X squared minus 11x plus 24. Is there a GCF? There is not. There's no greatest common factor between any of these three parts, so we can go ahead and follow our steps here. The first term goes in the top left, and the last term goes in the bottom right. So the first term in the top left, the last term in the bottom right. I'm going to rewrite this trinomial just so I have it. All right, multiply these two terms together. They multiply to give me 24x squared. Find two factors of 24x squared that when added together will give you the middle term, which is negative 11x. If they multiply to give me a positive, but add to give me a negative, what do their signs have to be? Yes, their signs both have to be negative. I have two x's here, so each one of them gets 1. What are some factors of 24, both of them being negative numbers, that could add to give me negative 11? Would negative 6 and negative 4 work? That would only add to give me negative 10. Would negative 12 and negative 2 work? That would add to give me negative 14. What are some other factors of 24? Very good, negative 8 and negative 3. They multiply to give me 24x squared, and they add to give me negative 11. So I found them. It doesn't matter which one goes where in the box. I'm just going to go fix this so that negative is in there with the 8x, so I don't make any mistakes. And now follow step 4. Go ahead and find the GCF of every row and every column. What is the greatest common factor between that column? It is x. What's the greatest common factor here? They both don't have a negative, so we can't take it out. The greatest common factor is 3. Check this row. The greatest common factor is x, and the greatest common factor here is 8. Now, the funny thing is here, I know that both of my factors have to have a negative, but in this situation, they didn't come out. But I need them there. So there's once or twice where this is going to happen, but I know that I need them there, and I'll show you when we check in a second. So this trinomial broke into these two binomials. The negative 3 and the negative 8 gave me the negative 11. The negative 3 times the negative 8 gave me the positive 24. So just be careful there. This is one situation when I have a negative and then a positive. My signs won't come out up top here, but down here led me to believe I have to have that. So be very cautious on this type of question. All right, let's try this one, and then we'll get started on homework. Look at this question. GCF? Every question so far, we haven't had one. Do I have one here? It looks to me like I do. If I do my factor tree here, I get a 2 and 2 and 2 Ks. So I'm just showing everybody, some of us like to see this. 12 breaks into 4 and 3. 3 is prime, it can't go any further. 12 breaks into 2 and 2. So they're all prime, and the K just means I have a K. So write these all out. 2 times 2 times 3 times K. Last one, and then we'll see what they have in common. 8. What's that break into? 4 and 2? 2 is prime, so circle it. 4 breaks into 2 and 2. So I just get 3 2's here. Remember, to be part of the GCF, they all must have it. So they have a set of 2's, cross it off and write it once. They have another set of 2's, cross it off and write it once. Do they have anything else in common? They don't. So the GCF is 2 times 2, which is 4. Now, I haven't seen a question like this, but if there's a GCF, I need to pull it out first, just like we did yesterday. Okay? So before I can go ahead and do any of my box method, I need to take that GCF out. So just like I did yesterday, how am I going to do this? Divide everything by the GCF. 4 divided by 4 is 1. K squared does not have any k's to divide with it, so leave it. 12 divided by 4 is 3. This k does not have any k's here to go with it, so leave it. And 8 divided by 4 is 2. So really, now when I go ahead and have my answer at the end, I need to keep this GCF. So yes, my trinomial is going to break into 2 binomials, but I still need to have that GCF out front with it because the whole thing is going to be part of my answer. So let's go ahead and follow all of my steps here. I'm going to give myself a little more room. All right, step 1, in the top left corner. So now I'm just factoring this part since I pulled out the GCF and I kept the GCF for later on in my answer. So the first term goes to the top, the last term goes down below. Remember, step 3, multiply them together. So 2k squared. So I want to find factors that multiply to give me 2k squared and add to give me the middle term, which is 3k. So if there's 2 k's, each one gets a k. What are the factors of 2? Only 2 and 1. Do these multiply to give me 2k squared? They sure do. Do they add to give me 3k? They sure do. So I found my factors. Doesn't matter which one you put where. Step 4. Find the GCF of every column and every row. The GCF here is k. The GCF here is just 1, right? And now find the rows. The GCF here is k, and the GCF here is 2. So I found my 2 binomials. Doesn't matter which one you put where, but you do need to make sure that you leave that greatest common factor out front. So this whole thing is my answer. Now, some of you are probably going to say, well, how can I check myself? If you want to check yourself, box the binomial times the binomial. So let's do that really quick on the side. So box that out, see what we get there. K1, K2, multiply every box. Combine the like terms. Remember, your diagonal has a like term, so k squared plus 3k plus 2. I still have that 4 out front. If I went ahead and then distributed the 4, am I going to get what I started with to check myself to make sure? 4 times k squared is 4k squared. 4 times 3k is plus 12k. And 4 times positive 2 is plus 8. And I sure do get what I started with. Go ahead and check Google Classroom so you can see which one we're good. Have a great day. Work hard. You know what I expect of you.